The question we are going to discuss today is: petroleum vapors are a dangerous substance and when mixed with air can be ignited. With this in mind, briefly describe an explosimeter or combustion gas indicator which can be used to check the atmosphere of a tank or pump room. Describe the explosimeter and its operation. Let's start with the first part of the question. An explosimeter or combustion gas indicator which can be used to check the atmosphere of a tank or pump room. An explosimeter or combustion gas indicator is a device used to detect the presence of combustible gases and vapors in the atmosphere of a tank or pump room. Its primary purpose is to ascertain the atmosphere in a cargo tank when planning tank cleaning in a too lean atmosphere or for evaluation of hydrocarbon gas prior to man entry, hot work, or other operations. The device works on the catalytic combustion principle, where a catalytic filament is heated by an electric current. A sample of the atmosphere to be tested is drawn over it, and combustion of the flammable gas on the filament further raises the temperature. When a percentage of the lower explosive limit, LEL, of an atmosphere is exceeded, an alarm signal on the instrument is activated. Let's move to the next part of the question. Describe the explosimeter and its operation. This is the diagram of an explosimeter. The combustible gas indicator shown diagrammatically consists of a Wheatstone bridge with current supplied from a battery. When the bridge resistances are balanced, no current flows through the galvanometer. One resistance is a hot filament in a combustion chamber. An aspirator bulb and flexible tube are used to draw a gas sample into the chamber. The gas will burn in the presence of the red-hot filament, causing the temperature of the filament to rise. Rise of temperature increases the resistance of the filament, and this change of filament unbalances the bridge. The current flow registers on the meter, which is scaled in percentage of LFL or ppm. A lean mixture will burn in the combustion chamber because of the filament. False readings are likely when oxygen content of the sample is low or when inert gas is present. The instrument is designed for detecting vapor in a range up to the lower flammable limit and with large percentages of gas-rich mixture. A false zero reading may also be obtained. The instrument and batteries must be tested before use, and samples are taken from as many places as possible, particularly from the tank bottom. It is possible to obtain a reading for any hydrocarbon but not for other combustible gases on an instrument which is scaled for hydrocarbons. Detection of other vapors must be by devices intended for the purpose. The explosimeter is primarily a combustible gas detector but will also give guidance with regard to safety of a space for entry by personnel. If a space has been ventilated to remove vapors, the remaining concentration can be measured with explosimeter, provided that it is below the lower flammable range. Generally, any needle deflection above zero is taken as indicating a toxic condition.